warahmatullahi wabarakatuh, and good morning everyone. Today we would like to present our group project Mass and Energy Balance. So before we continue our presentation, I would like to introduce our members. First of all, my name is Nonazla binti Khalid. Second, Muhammad Hadi bin Abu Bakar. Third, Batrisha Elina binti Mubarak. And lastly, Luqman Hakim bin Abu Ghaffar. So for your information, we all choose a vinyl acetate as our main product, and today we would like to explain and introduce to everyone about our product.
What is a vinyl acetate? Vinyl acetate is a colorless and flammable liquid that has a kind of smell that can be irritating to us. It is also a monomer that always been used principally in the production of polyvinyl acetate that come before polyvinyl alcohol and polyvinyl acetate resins. Besides that, vinyl acetate is absolutely soluble in organic solvents such as ethanol and ethyl acetate, but is sparingly soluble in water. So, for your information, vinyl acetate can be produced by mixing acid acetate, ethylene, and oxygen together. The chemical reaction will producing vinyl acetate and water with different boiling point. For instance, vinyl acetate has a boiling point of 72 degrees Celsius, while water has a boiling point of 100 degrees Celsius. So the differences of the two solvents can make it easier to be separated in the distillation. Moreover, the most important reaction of vinyl acetate is it is fast and exothermic, and due to the fact of vinyl acetate is an ester, so it presents the reactive properties of cyclic group. Lastly, vinyl acetate is widely used in a production. For instance, synthesis resin, textile, paper coating, and so on. We will move on to the next part, that is process flow diagram, process description, and calculation. So this is our process flow diagram of vinyl acetate, our product. And in the process flow diagram, we have 5 components, that is mixer, reactor, to separator, and distillation. So the production of vinyl acetate can be referred as the process flow diagram below, and it has stated the mass flow rate, input, output, and fraction that is contained in the chemical reaction. So the main process of the production vinyl acetate is the reaction between ethylene acetate acid with oxygen. So first, about 48,000 kg per hour of mixture containing 80% by mass of ethylene C2H4 and 20% by mass of acetic acid CH3COH as an input. Both feed are mixed together and producing a new mass flow rate of an output stream, that is M2. So after the mixing process, the output flow rate M2 is 49,000 kg per hour with the fraction of ethylene is 0.7980 mole and the fraction of acetic acid is 0.203 mole. So as we know, the input of the mixture is 48,000 kg per hour with the mass of ethylene is 0.8 mole and the mass of acetic acid is 0.2 mole. So in order for us to differentiate the excess and limiting, we need to find the molar flow rate of both true acetic acid and ethylene. So the first one is for ethylene, we need to times 0.8 mole times 88,000 kg per hour, and we get 38,400 kg per hour. And the answer need to be divided by the number of mole of the ethylene, that is 28, and the molar flow rate for ethylene is 1,371.4285 kmol per hour. So the next one for acetic acid, 0.2 times 48 kg kg per hour, and we get 9600 kg per hour. So for each mole of fluoride, we get 160 kmol per hour. After that, we need to do a table that containing two rows. That is what we have and what we need. To calculate the what we have, we need to divide the mole of fluoride that we had calculated just now with the smallest mole of fluoride, and we get the answer. And for what we need, we get the answer is 1 mole for both C2H4 and CH3COOH. So lastly, we can get whether we get the answer that C2H4 is the excess and CH3COOH is the limiting. So next, as we know, the output of the M2 is 49,000 kg per hour, and next we need to calculate the fraction of the C2H4 ethylene and CH3COOH acetic acid. So to calculate the fraction of ethylene, we need to do the calculation. M2 equal to M1 plus M6, and the M2 is 49,000 kg per hour times C2H4 equal to 48,000 kg per hour times 0.8 plus 1,000 times 0.6535, and we get the answer. The fraction of ethylene is 0.7980, and for acetic acid, we just need to minus the C2H4 fraction with 1, and we get the fraction of CH3COOH acetic acid is 0.203 mole.
So for the next one is we will go to the reactor for flow diagram 2. So this reactor will be containing a reaction between oxygen, ethylene and acetic acid in order to produce the product that we wanted, which is vinyl acetate. So M2, which is mass flow rate for acetic acid and ethylene, is 49,000 kg per hour with a fraction of 0.798 for ethylene and 0.203 for acetic acid. Will be reacting with oxygen with a flow rate of 2,000 kg per hour with a fraction of 1 mole. The result that we get for M4 after calculation is 51,000 kg per hour of mass flow rate for M4, and for the fraction we get 0.03 for ethylene, 0.29 for acetic acid, 0.57 for vinyl acetate, and 0.11 for water. Okay, so next we will see the calculation for this reactor. So the M2 that we got is 49,000 from the first one, and the C2H4 is 0.797, and for acetic acid is 0.203. That is the result. So how to calculate is, let's see for ethylene. So M2 is equal to M1 plus M6. M1 and M6 is the M1 is the fat and M6 is the recycle column from the previous slide. So M2 is 49,000. We are searching for ethylene, C2H4 for M2. So M2 equal to 48,000 times 0.8 plus 1,000 times 0.6535. We will get ethylene is 0.797. So then we only have two components in M2, which is ethylene and acetic acid. So after we get ethylene, we can just subtract it by 1. So 1 subtract 0.797, we will get 0.203. So for M3, we get, or we put flow rate as 2,000 kg per hour, and for oxygen, just one component, so it is 1 mole. So for M4, we have 51,000 kg per hour, which is we get from M2 plus M3, 49,000 plus 2,000, then we will get 51,000. So for the other components, which is vinyl acetate, we get 0.57. For water, we get 0.11. For acetic acid, we get 0.29, and for ethylene, we get 0.03. Next, for the product, after the product, we have to separate it because of vinyl acetate is mixed with water, is mixed with ethylene, and mixed with acid acetic. So we have to separate it. We just want the product, so we will have to put it in the separator to separate it. So the separator will go to two sections, which is top stream and bottom stream. So what goes to the top stream is the product with low boiling point, which is ethylene with a 72 degrees Celsius of boiling point. We go to the top stream with a flow rate of 2000 kg per hour and with mass fractions of 0.765. What goes to the bottom stream is the high boiling points such as water, acid acetic, and vinyl acetate with a mass flow rate of 49,000 kg per hour. We get the mass fractions for acid acetic is 0.3018 for the acid acetic. For vinyl acetate, the product, we get 0.5932, and for water, the mass fraction is 0.1144. Next, we will go into the calculation for the first separator for this flow diagram. Okay, so as we know, the M4 is the product that we get from the reactor. So M4, the flow rate for M4 is 51,000 kg per hour, and with the fraction for ethylene is 0.03, acetic acid is 0.29, vinyl acetate is 0.57, and the fraction for water is 0.11. So let's take a look on how we calculate the M5. So M5, we assume it is 2000 kg per hour. So the formula on how to get M5 is M4 equal to M5 plus M2. So as we know, at the top stream we only have ethylene, which is because of the low boiling point, which is 72 degrees Celsius, if I'm not wrong. So how to calculate is 51,000 times 0.03 from the M4 equal to 2000 C2H4, which is the ethylene that we want for M5, plus 49,000 times 0, because at M8 we have no ethylene, so times 0. So the ethylene that we got for at the top stream is 0.765. Next, we will see on how we calculate M8. So from the formula is M4 equal to M5 plus M8. So as we know, M4 is 51,000, and we have calculated that M5 is 2000 kg per hour plus M8 that we want. So M8 is equal to 49,000 kg per hour. So we will look into how to calculate the fraction of each components in M8. The first one is for acid acetic. 51,000 times 0.29 equal to 49,000 times acid acetic on M8. Acid acetic on M8 equal is 0.3018. So next, we will calculate the water on M8. So we have water on M4, which is 0.11. We multiply it by 51,000 mass flow rate from M4. Because of at the top stream we have no water, so we just put it as 0. We just equal it to 49,000 times water from M8, we will get the answer of water is 0.1144. And for the last one, for the product that we want is vinyl acetate, 51,000 times 0.57 that we get from M4 equal to 49,000 times vinyl acetate on M8. And again, we have no vinyl acetate at the top stream, so we just equal it to M8. So C4H6, which is vinyl acetate, equal to 0.5932. From the previous part, the ethylene will flow again into another separator to make a two part, which is the first one is we flow the stream into the mixture by recycle process, and the second one we purge the ethylene away from the diagram. So we move to the recycled part first. The recycled part, we use 1000 kg per hour flow rate, and the fraction is 0.6535. And for the second part, which is the purge part, we use 1000 kg per hour flow rate, and the fraction is 0.3465. So for the calculation of the separator, so what we have is M5 equal to M6 plus M7. So for the flow rate to the calculation, we just assume the flow rate is cut to the half, which is the M6 equal to 1000 kg per hour, and M7 also 1000 kg per hour. So for the fraction, we can use the equation, the formula M5 equal to M6 plus M7 to find the fraction in M6. We can use M5 which is 2000 multiplied by 0.765 equal to 1000 multiplied by x. So we just calculate, and the answer will be 0.6535. And then for the fraction at M7, M5 equal to M6 plus M7. So M1, M5 is 1, M6 is 0.6535, and M7 is our x. So after we calculate, we will get M7 equal to 0.3465. Lastly, stream A that have vinyl acetate, water and acetic acid will flow into the last part of the plant, which is the distillation column. After the distillation column, we will see presence of two part of stream, which is the M9 and M10. So in M9, we will have our product, which is the vinyl acetate, while M10 will have water and acetic acid. So we move for the M9 first. In M9, we will have a 30,000 kg per hour flow rate, and the fraction of vinyl acetate is 0.9688. For the M10 stream, there will be a 19,000 kg per hour for the flow rate, and the fraction of water is 0.2950, and for acetic acid is 0.7783. Lastly, to calculate the distillation column, we need to know the input and the output. Input is M8, output is M9 and M10. So for the flow rate, M8 is 49,000 kg per hour, M9 is 30,000 kg per hour, and M10 is 19,000 kg per hour. So we done with the flow rate. So we move for the fraction. For the vinyl acetate is located at M9. So we can use the formula M8 equal to M9 plus M10. So
by 0.5932, yes, equal to 30,000 kilogram, 30,000 multiplied by x plus 19,000 multiplied by 0. So after we calculate, and last we will get 0.9688. After that, we move to the M10, which is water and acetic acid lah. So we move for the water first. We move for the water. From the water, we can use 49,000 kilogram per 49,000 multiplied by 0.1144 equal to 30,000 multiplied by 0 plus 19,000 multiplied by x. So after we calculate, we will get 0.2950. And lastly, acetic acid are also same like water. 49,000 multiplied by 0.3018 equal to 30,000 multiplied by 0 plus 19,000 multiplied by x. So lastly, for acetic acid, we will get 0.7783.
Overall, to determine the optimum process to produce vinyl acetate monomer is the acetylation of ethylene using acetic acid. The process is divided into two parts, the reaction and the separation system. With regard to this reaction is very related to the temperature that will determine the selectivity of the process that describes the two parallel reactions. In addition, based on the separation system, it is clearly necessary to separate the liquid phase from the gas phase with the objective of purifying the final product and redistributing some unnecessary material. Analysis regarding the total production of vinyl acetate process is necessary to determine the best way to use the energy in the process so that it can be used to exchange with other stream and to make a reduction of energy consumption. In conclusion, vinyl acetate is a versatile chemical with various potential applications in various industries such as adhesive,